I'm Donny. I'm a developer at PagerDuty, and I'm one of the people who run the Failure Friday exercise. Today I'm going to tell you about what Failure Friday is, how you can get started running it, and some of the new things that we've done with it. So we're right after lunch. Some of you may be jet-lagged or tired, so I'm going to start off with my conclusions. Number one, Failure Friday is awesome. You should do it. Number two, when you do it, don't automate it, at least not right at the beginning. And number three, when it starts to get boring, switch it up and add in new things to keep it being exciting and to keep on finding new things. So can I get a show of hands? How many of you have heard of PagerDuty? Pretty much everyone? OK. For those of you who don't, the very short version is that usually you have lots of different monitoring systems. All of those connect up to PagerDuty. And when they detect a problem, they'll send an event to us, and then our software will call or text or email you to let you know that you've had a problem so that you can fix it quickly. One thing is that we care a lot about high reliability because you guys rely on us. When your software is down, it's very bad when we're down and we can't tell you that you yourselves are down. So because we care a lot about this, we put a lot of effort into making sure that our own systems are reliable. So I want to talk about that for a little bit. One approach that you could take when you're trying to make reliable software is take one machine, get really high quality components, get a really nice machine. You can put it in a data center like this, which is a data center that is built in a repurposed nuclear bunker, so that you can survive whatever environmental catastrophes you have. But of course, the downside of even if you put it in that, you're still at the mercy of network connections. If you have any problem with network connectivity, it doesn't matter that your one special machine is up if nobody can actually connect to you. Your service is still down anyway. There are cables, fiber optic cables through the ocean that transmit a lot of the data. This is one of those cables. And this is a shark attacking one of those cables. So that this actually has happened a few times in the past. Sharks have gone, bitten fiber optic cables, and caused network disruption as a result of that. Now, in reality, this is actually extremely rare. Most of the network cable disruptions are caused by things like boats dragging their anchors along and destroying the cable rather than shark attacks. But still, failures like this can happen, and the best way of dealing with them is just to accept that they're going to happen, embrace that failures will happen, and design your software around that, expecting that it will happen. One of the exercises that we do at PagerDuty to try to deal with this is an exercise we call Failure Friday. Failure Friday is a fault injection test that we run against our production environment. So a fault injection test being things like rebooting machines or using IP tables to cause a network partition. And we do all these things against our production environment. Now, there's a lot of fun sayings on the internet about testing in production, like, I don't always test my code, but when I do it in production. Or everyone has a testing environment. Some people are lucky enough to have a totally separate environment to run production in. And Failure Friday is not about this kind of thing. It's not about testing in production because you have no other choice. It's about testing in production because you're confident that your software will work, and you want to verify that, and production is the true test of whether or not you can actually handle these kinds of faults. So I mentioned before the fault injection test portion. These are the basic attacks that we run against all of our services, all of our machines. So stopping and starting a process, suspending and resuming a process, network isolation, things like that. Actually, on this one, I have the commands that we use to run these kinds of things. So basic things like just stopping a process, waiting to see what happens, making sure that other machines take over. Another one, so suspending and resuming one, kill-stop. This will leave a process still running, but it won't get any CPU time, so it won't be doing anything. This is good for finding things like server-side timeouts that should be there but aren't. For example, if you have an application server that has a database connection, maybe it starts a transaction and starts doing things. If you do kill-stop, then you have paused it there. But from your database server's perspective, it's just not getting any new information. But the TCP socket is still open. So if you don't have any kind of server-side timeout, then it will stay like that, and your database might have tables locked or other things like that. So doing kill def stop and then waiting would reveal those kinds of things. Another very simple one is just rebooting a machine and making sure that everything comes back up as it should. Another is simulating network isolation. We do that just using IP tables. In our environment, it's a little bit easier because we use IPsec, so we can block just a couple of ports that all of the encrypted traffic goes through, and that will leave SSH unaffected, but it will block all the other stuff. But in your environment, you can do basically the same thing, just set up the IP tables rules to allow SSH or whatever other special ones you want to allow, and then block everything else. And the way that we run this kind of experiment is we'll first run it on one machine, like one application server, and then after we've done that and we've verified that things are fine, then we'll move on to doing it all of the application servers in one data center, or in your example, it might be in one availability zone, whatever your unit of fault tolerance is. And then another one that's really fun, adding network latency and packet loss. So this command will add 500 milliseconds of latency plus a random amount from 0 to 100 and 25% packet loss on top of that. This one, you might think that it's not doing too much different than network isolation, but actually it's a lot harder to survive than network isolation, because having a slow machine is usually worse. When you have a slow machine, sometimes it can still connect. It'll just be flaky rather than being just hard down where you can easily detect that. One thing that you often find with that last one of adding packet loss and network latency is clients that should have had their timeouts tuned. So a lot of the times when you're using an HTTP client or any other kind of client like that, you just leave the timeout as whatever the default of the library is, and you don't pay much attention beyond that. But if you start adding this kind of stuff, network latency, then you'll find that it really does matter what timeout you have. It can affect the throughput of your service a lot when you have this kind of network latency. You also find that it pushes you to use a little bit of a smarter client, one that might have built-in health checks of the servers that it's trying to talk to, rather than naively talking to the same server, even if it's going to be slow. This would be on the opposite side of the one that you had added packet loss and latency to. So the Failure Friday exercise that we run, the people that we have there are usually the on-call for whichever service it is that we're targeting then, usually some of their teammates, particularly the newer ones. It's a good way for them to learn. Also, having an ops person or an SRE person, they're just generally useful when you're doing this kind of experimentation. We also run this similarly to our outage calls. So we have one person, their role is incident commander. They're the one making the decision about whether we should move on with it or whether we should cut it short and that kind of stuff. We also have someone who, again, this is like how we run our outage calls. They're the scribe. They just record what we've done at what time to make it a little bit easier to figure out if things have gone wrong or if things do look a little bit off, what it was that caused it, especially if you're going back a little bit later. You don't have to go through logs to reconstruct what things people were doing. And we just use a simple a Slack chat room. We have a Google Hangouts call or a BlueJeans call going on to coordinate. And broadly, we just follow the plan that we had come up with before. You do one experiment, you wait for a few minutes and see what happens, and then you undo it and bring your system back into a healthy state after. So before that was some of the basic things that we do to everything. We also have some kind of more unique one, larger scale ones that we do. One of them is if you have a disaster recovery site, you can use this to ramp up traffic there. So most of our services are run in multiple data centers. They're clustered. We have all data centers are active, but for one of our older services, it is still in kind of like a main data center, but with a disaster recovery data center for failover. And it's not a true passive system because we have it set up so that 1% of our traffic goes to our DR site all the time. But we can take a failure Friday and we can ramp up traffic to 100% to make sure that there isn't anything weird, that we can basically still handle that. Otherwise, you just have this idle data center and you wouldn't really know that it would be able to be used in an actual disaster. Another one is, again, for most of our services, we use clustered databases, stuff like Cassandra. But for one service, the same one as the first one, it has a master, at least for a lot of the traffic. And we use Failure Friday to fail over that master to make sure that we still can. Another fun one for us is taking down one entire data center. We expect to be able to handle this, and so we can use Failure Friday to test that. Very slowly take down a data center and make sure that everything is still going fine. In your environment, it might be one availability zone, or again, whatever kind of fault you expect that you should be able to tolerate. There's a lot of benefits that you get from running these kinds of exercises. There's a lot of the technical ones, like finding out machines that when they reboot it, processes don't come up, or we found a few times now a single machine that you can add latency to and cause many others to fail because of that. But there are also some other more human benefits, like training new people, getting them comfortable running commands in our production environment. In an outage, you might have to be running stuff on production anyway. It's a lot better if you're not nervous doing that because it's the first time you're doing it. You instead have done it many times in Failure Friday before. Another big one, the second last one, making sure that your monitoring and alerting works. While we're running these experiments, we're watching what alerts come in and making sure that if things should be paging us, then they actually are. Your monitoring and alerting is usually something that's pretty hard to test in like a unit test way, especially for something like when this one service is being slow, I want to get alerted for it. A good way of doing that is just to make it slow and make sure that you actually do get alerted. Another good one is learning useful dashboards that people have. I don't know about your companies, but at mine we have lots and lots of dashboards, too many to keep track of. During Failure Friday, when things are going on, people are pasting in graphs from the most useful ones showing what's going on. And then you can learn from that to see what the actual useful dashboards are during an outage. My advice for getting started on this is, number one, again, don't automate it. At PagerDuty, we started this about 3.5 years ago, almost 4 years ago, and it's only very recently that we've started adding automation. Up until then, we've just run commands manually. You SSH into a machine, and you do that there. I think it's very easy to fall into the trap of, we're all developers, you hear about a cool idea you want to do, so you go and you write a bunch of code to automate it. You could take a day and have a really nice automation script for doing this kind of testing. But then if you haven't gotten people to buy in that it's a good idea to do, it won't get used. It's also safer to do it manually, at least in the beginning. Whatever script you come up with won't have as quick fallbacks as you just going in and undoing what was done that caused the problem. The other thing is that you should pick reasonable things that affect your environment. So a few of them are going to be pretty common, things like rebooting a machine. That can happen to anyone, but the other stuff about network isolation or packet loss and latency, the unit of failure that you're using, you should tune to whatever it is you expect to be able to handle. If that's one availability zone, sure. If it's one region, then do that, but tune it to whatever is reasonable. And also, when, oh, sure. The question was, how do you build these recipes for Failure Friday? We have a basic set that we do for pretty much everything, the ones that I had outlined, stop a process, reboot, network isolation. But on top of that, you can also add specific ones for whatever service you have. But you can get pretty far just with a basic set of things that can happen to machines, essentially. Oh, sure, another question. How do you make sure it doesn't impact production? So I will finish bullet point 2 and then move into that, which is when you first start doing these kinds of experiments, they're riskier. So you should be testing in a staging environment first. After you've done them for a while and you're more at the stage of just kind of keeping up the status quo, making sure that you still fulfill the guarantees that you have, you can probably skip doing it in staging first. So when we are first doing these, when we're doing something that I would consider risky, we'll do it in staging first. But now, as a general rule, we don't do it in staging first. We do it in production. And if you do have production impact, you can't guarantee that you won't have production impact from that. It does happen, and it has happened to us, but it's much better to have it happen early in the afternoon, during business hours. Everybody is awake. Everybody is paying attention. A lot of people are monitoring dashboards manually, so in some ways you have better alerting than you would otherwise because you have your automated alerting and humans watching dashboards. And on top of that, you can generally undo what you've done really quickly. So if you do have an impact from adding network latency, for example, as soon as you see that, undo it. Or wait for a little while to verify what the impact is. If it would settle down after, maybe health checks would kick in and stop using the slow server, or you could undo it. But broadly, you will have some impact if you keep on running these eventually. The pitch is that it's worth it to do it during business hours and to find out early while you can undo it and then go and fix it asynchronously, like create a task to go and fix the underlying cause of that problem. Any other questions before I go on? Cool. So the last thing is that it can be helpful to track whatever results you have from this kind of exercise in whatever ticket tracker you use. Use a label or a tag or whatever, and you can use this to justify the cost of doing this kind of exercise. Especially if it does cause any kind of downtime, you'll be able to look back and see all of the things that you've caught before they had an impact. Or if it isn't catching things for you, then maybe you don't need to do it. But by keeping track of what stuff you found, you'll be able to figure that out. So ideally, your Failure Friday should look like this. You come up with your plan, run it in production, and everything goes well. Ideally with less celebration than that. It should be the normal thing that it goes well. And for the most part, it does. I like that GIF. So that's kind of the basic thing that we've been doing for several years. We've also added a few new things to this exercise overall. The basic tax that we have from 2013, around the middle of 2013 that I showed earlier, these apply to pretty much any service. And now we still use the exact same ones. For the basic set that applies to everything, we haven't found a need to expand beyond this. Some other stuff we've done, though, is adding on kind of a game day type thing. What we wanted to do was improve our major incident response. And so the idea was that we planned out an attack that we ran in secret. Actually, I should mention, for the Failure Fridays that we do normally, the plan isn't secret. We have it in a wiki page. It gets sent out in the calendar invite. Anyone can look at exactly what the plan is, and people do look at it as we're following through. With this one, we tried out something different. We tried out doing something in secret. So I prepared a change that made it look like one of our services was having a major incident, even though it wasn't, and it had no impact. And I had a coworker deploy it. And then the idea was that people would respond, and then we would have kind of a retrospective after just on our incident response. So after we have a major incident, we always do a postmortem anyway, but usually that postmortem happens a few days after the incident, and the focus is more on the technical challenges that we had. If there was any really big communication challenge, then we would talk about that as well, but it's easy to forget after a few days. So with this, we were doing it and focusing only on the communication because the technical change was just some little change that, that someone deployed. And this one, it was the first time we'd done this, and it was kind of okay. It worked out a little bit weird, where it was kind of this half surprise thing where we did it during Failure Friday, but people didn't really know what was going on. And what happened was people got the page, and then nobody really responded to it. And then a few minutes went by, and people still weren't responding. And eventually what happened was someone who wasn't in on Failure Friday came in to the room and saw that we were having this, and then started getting people, what are we doing to investigate this? And then we went from there normally. But the thing is that never happens in our real incidents. Nobody ever gets paged and then ignores it and throws it away. I think it was just something kind of weird where it was this half surprise thing, and maybe there was kind of a bystander effect of the first few people didn't respond, and then everybody took their cue from them and didn't do it. So if I were to do this over again, I would either do it completely as a surprise, or more likely just be more upfront and say that we're going to cause an incident, respond as normal, and then we're going to talk about it after and see what we can do to improve. Another one that we ran was we caused a small database issue. For this one, we did cause a real issue, just one with a minor impact. But right before the page hit, I messaged most of our ops team and told them that they weren't allowed to respond and that other people had to. So for this, we actually did have a pretty good run book for this particular incident, but there was still some value in other people going through and running through it. In this case, the run book was just run this command on the database server, take the top result from here, copy and paste it into this other command, and then you're done. But it took a long time to get it done because people were kind of uneasy about it. I think with a lot of run books, people often forget to add in the little things that you do, like when you run that first command, maybe there's a second one that you'll often run to check to see whether the results were valid, or maybe you run it and then you wait for a few seconds and run it again. Things like that increase your confidence. Or after you run that second command that's supposed to resolve it, knowing how long it's supposed to take before it will resolve. Should it happen instantly? Is it going to be 5 minutes? So things like that made people uneasy. And there's a lot of variations that you can run on things like this. So one, which it might be true for a lot of you here, is that most of your team is out at DevOps. What would happen if you were paged for a service that you're responsible for? Other ones, in our case, we have 2 major offices, one in Toronto, one in San Francisco. What we would like to do at some point is run one of these, but one of the offices can't respond, pretending that there was some natural disaster there. Another one that we've added is a tool called Chaos Cat, which is a complete ripoff of Netflix's Chaos Monkey, if you've heard of that. But a monkey, to me, kind of has the connotation of being evil, whereas cats, they're not evil, they're just indifferent. They'll just knock over your server, and if it goes down, it's your fault. So what it does is automates part of this routine Failure Friday plan that we do. Right now, it automates rebooting a random production machine and also adding network latency and packet loss to a random machine for a specified amount of time. And the goal is eventually it will run the entire basic Failure Friday plan that we have to free us up so that we can do other things during that time. And I also want to put another reminder that it was 3 years before we actually started doing this kind of automation. You can go very, very far just manually SSHing into a machine, running commands there, maybe using a tool like Knife with Chef or other things like that to run it on a bunch of machines at once, but not having any automation beyond that. Also a comment about rebooting a random machine. For this, at least so far, it really is a random machine. There are no exceptions. This includes not just application servers, but also database servers, load balancers, any machine. We don't have any exceptions coded into it. And it actually hits database servers and load balancers and things like that more often than it should. In the initial version, it did just take the list of all of our production hosts, pick a random one, and then reboot it. But the problem is that we have a lot of machines that are basically just clones of each other. You might have a service where 100 100 application servers, they're all basically the same. There's not going to be a problem that's specific to one of them. So really, you're just wasting time if you're going through and rebooting all of those. So the solution that we used is that we first pick a category of machine. So something like Service A application server, or Service B database server, or Service B application server. Those would be a category of machine. And then after we pick that, we reboot a random instance of that category. And so then you don't have this problem of having one type of machine where you have a ton of them and they get hit by this all the time. Instead, you get each kind hit fairly often. Another one that we've started to do is that having a single failure Friday for the whole company can be a bit of a bottleneck if you're trying to spin up a lot of new services. So we're spinning it out to let individual teams run their own failure Friday type scenario. For these, though, what we've done is we've focused a lot more on getting the team ramped up in on-call stuff. So it's a mix of doing failure Friday type stuff of testing the system, but also getting new team members to understand the system better. So typically what we've done is we've had the most experienced member of the team come up with what kind of scenario they want to run. And for these, it usually is pretty focused on something specific to the service, some kind of page that they get fairly often or somewhat often. And then they'll cause it. And for this one, we do have it done in secret. They come up with the plan, they run it, and then their team members don't know what it is that they're causing. They just get hit with the page, and they have to go and solve it. Another thing that we've done with this is pulling up a previous period for a dashboard, and in some cases pulling up a period from an outage. In other cases, just pulling up a period that kind of looked a little bit weird, but maybe was fine. A good example for that is if you have a service where you don't deploy to it very often, the period where you do a deploy usually looks kind of weird, kind of iffy, even though it's normal. And initially, I had picked those kinds of things, the dashboard review, just as a filler item in between causing pages, but it ended up being one of the more valuable parts there. Usually when you're on a team, if you're trying to learn dashboards, someone might run through and tell you what each graph means, and then you forget it pretty much right away. It doesn't really sink in. But instead, if you're shown the graph for a certain period, and what we would do is we would pretend you're on an incident call and you have to answer, is your service healthy or not? Then you have to actually start going through and really thinking about what the graphs mean, and then it really sinks in which ones are useful, what they mean, and then you actually learn it. Whoops. The other part is for this kind of thing, I didn't want it to be like an interview where the focus is on one person trying to solve the page, but I also didn't want to let the whole team do it, because then some people might not learn as much because they're not really thinking. So what we've done since the beginning, which I think has worked pretty well, is we always do these in pair. So the one experienced person will have caused the problem, and then you have a pair of people. They're both allowed to investigate and to take action to try to fix it, and the rest of the team can watch, but they can't help. That way, the pair learns quite a bit, and even though it's not exactly how you would respond on a normal incident, you would just have one person, I think it works out better because then you're not kind of in the hot seat with everybody focusing on you. Maybe some of them already know how to solve the problem and you're just struggling there. So I think doing it in pair works pretty well. I also want to talk about some of the plans that we haven't done yet, but we would like to do. So one I had mentioned before, there's lots of variations of one team is unavailable or most of the team, or one office is unavailable that you can run. Another good one is if your CI server is down, if you rely on that for doing deploys, how would you fix it? Would you need to spin up a new one? Do you have some manual process that you would have to use? Another good one is how many of you use GitHub for work stuff, like hosted repos? A few of you. And how many of you would be able to deploy if GitHub was down? One person. So for everybody else, is that a problem? Like, if GitHub was down and if you needed to do your deploy, you would have to come up with some other way of doing it. Maybe you have it planned out already and you're super prepared, or maybe you need to come up with one on the fly. In any case, trying it out in a scenario like this, a technique that we've used for similar things is just do a fake bad deploy, just have it log something on every request, and then you can watch to see how long it takes you to do a rollback or to deploy something new. Another one is that we rely quite a bit on chat ops type stuff. We have one chatbot in particular that's extremely useful. It's used during a lot of outages for figuring out what IP maps to what machine. We have that other places, but it gives you a nice command where you can just paste in output from some command and it will do it. We also use it for provisioning new machines, for deploying, for rollbacks. So if Slack, our chat room, was down, then we wouldn't be able to use that, and it would be quite a bit more difficult. So it would be nice to do a simulation of if Slack was down, you're also losing a communication mechanism, but also the chatbot. What would we do? Would we need to spin up another one? Do we have workarounds for these things? Something good to find out. Another cool thing that you can do is you can do certain kinds of capacity planning. If you want to find out what your capacity is for a linearly scalable system of like app servers, just take down app servers until you start having problems, and then you found out what your capacity is. Easy thing to do. So all of this might sound maybe a little bit scary, but hopefully pretty reasonable. This is going to be probably the controversial part of this presentation, which is about error budgets. How many of you have heard of the error budgets that are proposed by Google SREs? A couple people? OK, good. So an error budget stems from this idea that going for 100% reliability is the wrong target for pretty much everything. And there's lots of reasons to back that up. I'll give you just a couple. One of them is that because there are so many other things in between your users and your service, things like their machine could crash, or they could have a flaky Wi-Fi connection, or their ISP might be down. Because of all of those things, they can't actually tell the difference between 100% availability and a certain very high level of number of nines of availability. They can't tell the difference anyway, so why bother aiming for it? The other is that you can go very, very far. You can put in a huge amount of effort aiming for really high availability, and to the extent that you're aiming higher, it costs you more in terms of complexity, in terms of being super careful before doing deploys, all of those things. So the idea is that instead of aiming for 100% availability, pick some target and aim for that. So if you look at the number of nines of availability over some period of time, like a week or a month or a year, that gives you the amount of time that you can be unavailable but still remain within your target. So if you have a service where maybe it needs to be up 1 day per week just to run a batch job, and it doesn't even matter what day of the week it's up, it just has to be up, then you can aim for 90% availability. It can be down for 3 days, and you don't care because as long as it runs during the week, you're fine. As you start aiming higher, though, pretty soon you need to have that one machine be a bit more reliable. Before, you might have been able to just have it maybe in your house or in a closet, whereas if you're aiming higher, you have to have it in an actual data center. When you start aiming higher still, you have to have, instead of just one machine, a backup, but maybe you could have kind of a manual process of switching to the backup. If you go higher still, you would want an automated process to go to the backup. Even higher, you start having to use clustered solutions, distributed systems type stuff. And the idea, though, is that you have some target that you're aiming for. Now, when you use this budget, or when you use this concept as kind of a budget, it can help you make some of the decisions about what trade-offs you need to have with your system. So one thing that you can use it for is determining the trade-off between doing new product stuff versus focusing on reliability. So if you treat this as a budget, if you have your team, you're shipping lots of new features, you're moving quickly, and you're within your budget, then you can go nuts and keep on going. You're obviously making the right trade-offs of how much effort you should be putting into reliability versus new feature stuff. But if you start to have downtime, then at that point, you can hold off on new feature development and instead work on features that will improve reliability, like canary deploys or automated rollbacks, faster rollbacks, things like that. Now, one of the things that you can use this error budget for, and something that I'm going to argue that you should use it for, is basically burning it. So if you have a service and it happens to have really good reliability for a few months, you get lucky and it stays up, what you can do is use up your budget by deliberately taking down that service. Take down every instance, leave it down for a little while, and use up your budget. Now, when I first heard that idea, I thought it was stupid. Like if you get lucky with your service and maybe you have a service running on one machine and it happens to be up for the whole year, why would you want to take it down? You got lucky, you should be happy. But instead, that can cause some problems that taking it down would fix. So one of them is that if you have a service that happens to have better reliability than it was designed for, you might have a high availability service depend on your low availability service. So back to that example of you have a service that runs on one machine. Maybe you know it's only running on one machine. If it dies, you're going to have to restore from backup, and it'll take 2 or 3 hours. But if you have a high availability service accidentally depend on it, and you have really good availability just by chance, if it goes down for real, then your high availability service is going to be down for a long time while you restore from backup. Instead, it's much better if you take that low availability service down intentionally and have that other team come running to you and say, no, you have to bring it back up right away, and then you do that. But at that point, you've realized that you have that hard dependency, and then you can fix it. So you either have to take that low availability service and put more effort into bumping up the availability, or you can do things like introduce a caching layer, or somehow removing that hard dependency. Maybe you can work around so that if that other service is down, the high availability one can operate in some kind of degraded mode where it can still do most of what it needs. But it's much better to find that out when you bring it down in a way that you can quickly bring it back up, rather than having it crash and having to restore from backup or whatever other wait for the network partition to heal. Now, the other thing that it does, having this error budget and taking it down intentionally, is it provides a really strong gut check that the level of availability that you picked is the right one. So this target for what availability you're going for should be decided by your product team or your business team with whatever your customers expect of you or whatever you need to provide them. Now, they would want you to have a lower availability target because it would let you move faster. So going for a higher target, you have to put a lot more effort into designing things. It's going to take a lot more time to build out the system. So they would want to, if they could, have you go lower and maybe hope to get lucky with this. But the thing that pushes you against aiming for too low is if you deliberately take it down, if you happen to get lucky, then it provides that check of they can't aim too low because you will take it down, and they don't want to aim too high because it's going to cost a lot more in terms of complexity and engineering time. And so those two things should balance together to push you towards whatever the right target is for you. And then if you have picked the right target, you're going to make better decisions on whatever trade-offs you have to do in terms of engineering effort to hit that target. So my conclusions, once more, Failure Friday is awesome, and you should do it. When you do, don't automate it, at least at the beginning. And if it gets boring, start adding new things. Do some of the things that I've talked about here that we either have done or that we're planning to do, and keep it interesting. And that's all I have. Thank you all for listening. Yep. Do we test for multi-region failures and timing how long it takes to switch over? So a multi-region failure is not one that we design for. We run across 2 different providers in a total of 3 what you would call regions, so 2 AWS regions, plus we have a third what would be a region, but with a different provider. So we only expect to have one region go down at a time, so we don't do multi-region failures. For timing how long stuff takes to switch over, not exactly. We pay attention more to how many things are within SLA and making sure that errors are reasonable or low to non-existent while we're doing that switchover. Any other questions? Yep.
Is it regular practice for all your teams?
Is it regular practice for all our teams? Pretty much. We have 2 people, myself and one other person, who pick a target for Failure Friday each week, and it could be any team that gets picked. We pick, the way we pick is basically any new service is kind of automatically at the top of our list of what we want to test, and beyond that, ones that we haven't tested in a while, we'll push them. So by default, yes, it is basically any team could get chosen. Yep.
Do you aggregate some knowledge base based on your experiments?
What do you mean?
I mean that you run some experiments and you understand how you need to design your services, some patterns, anti-patterns, and so on. So do you aggregate it somewhere?
Right. I'll repeat for the mic. So it's, do we have some kind of knowledge base of the patterns that we find useful for building systems to withstand these kinds of attacks? We don't have an explicit knowledge base, but it is just kind of within the engineers. You learn it because many of our systems are built that way, and so all you have to do is look at an existing system to know about it. And some of this stuff probably should be written down, but the way that it does tend to happen is if we're running one of these scenarios and a new service is having problems, people who are there, a lot of the people aren't just specifically on that team. There are other people who are just interested in attending a Failure Friday to see what happens. They'll pipe up and say, oh yeah, this happened with this other service. Here's how to deal with it. So we help in that way. Other questions? Yep.
Has your Failure Friday ever gone out of hand? Like, or do you only do Failure Fridays on services that you know should survive that type of test?
So has Failure Friday ever gotten out of hand, or do we only do it on services that we know would survive? If we knew for sure that it would survive it, there wouldn't be any point in doing it. You're nodding along, but we won't do anything that we know would cause an outage. And if anything is particularly risky, then we would try it in staging first, and if we found something there, then we would fix it with development time, but then we would run it again in production. So having a major problem stemming from Failure Friday is pretty rare. It does happen, but they are usually short-lived. I don't think any have been basically uncontrollable. Any other questions? Yep.
Do you have items that you don't have enough incidents in production, so you need your own?
Well,
Like if your system is crashing constantly, do you need these additional?
so it's the comment is that do we have so few incidents that we need to cause more in production? And if you're in a situation where you have a lot of incidents going on, do you need to do this kind of thing? I would say you probably don't need to do the individual team Failure Friday that we do. We call it on-call osmosis. That's the one for training new teammates, basically to be able to operate the system, to be able to deal with it. If you're already drowning in operational work, then if you run Failure Friday and you find more things, are they going to get done first? If not, don't bother doing it. So if you're already drowning in operational work and you're already going as fast as you can to fix the most important things that are actually happening, then you probably don't need this. It's after you have a bit of slack time, when you can kind of work ahead of not just the things that you are suffering right now, but being proactive about what if a data center goes down, what if an AZ goes down, then you would want to run this to find new things. This is only going to tell you more things that are wrong, though. Any other? Yep.
Do you still have incidents in production environment?
Do we still have incidents in production environments? So the answer in any way is yes. So we have a lot of incidents that we have are minor ones, like one individual team gets paged. In fact, just one on-call gets paged, but it's something that doesn't affect the core service. If one machine goes down, you might get paged to go and fix it. If latency is a little bit high on this service for a liking, someone would get paged and they would go and investigate. But those things generally don't take down the service overall. If it does escalate to affecting multiple people beyond a certain threshold, then we kick off a major incident, and then one person from every team will get paged, as well as an incident commander and the backup IC who will then act as scribe. And then we start a video call and coordinate there and try to fix it as quickly as we can. But yeah, those things do still happen. The best that we can hope for is just to be able to fix them quickly. And we do Failure Friday to try to be proactive about finding new things that would cause these kinds of problems. But every time we have a major incident like that, as I said before, we run a postmortem, we figure out what the causes were, and then we go and we fix those things. This is about finding extra things before they actually happen.
Do you have any probability matrix for emulated incidents? I mean, you try to emulate latency issues for some nodes. Do you know in reality how much time this incident happens in production environment? Do you measure it somehow?
Okay, the question is about, do we monitor how often basically the things that we're testing actually happen in production? Basically, no. So for those kinds of things, a few people just kind of keep track of it in our head. For example, the numbers that we pick for latency and packet loss, they're just kind of things that we've seen. We don't keep super good stats on that. It's just we know that we've suffered latency that was as bad as that, packet loss that was as bad as that. We do have regular production node reboots just from AWS or whatever, but we don't specifically keep track of what stats we have. It would probably be a good idea to do, but part of what we do with ChaosCAD and with Failure Friday is just bumping up that base error level so that they happen often enough that you catch them. It would be nice to prioritize to do the ones that would actually happen more often first, but Any other? Yep, go ahead.
Do you have any metrics as to how many production events you had before you started Failure Fridays as opposed to when you started?
Do we have metrics on how many we had before we started Failure Friday versus after? Not exactly, and it's very tough to determine because we've been doing Failure Friday for a long time. So right now, for example, the company is 250 people. 4 years ago, or just under 4 years ago, before we were doing Failure Friday, it was like 40 people. We have many, many more services now. So I don't think you can definitively say, based on stats in that way, that it has helped. The only thing we can say, though, is that we found tons and tons of things. They go in our Jira tracker. We have found tons of things that we know will happen because we have actually made them happen by rebooting a machine or network isolating. So I think it's more useful to look at from that perspective about what things you found there and potentially try to tie them back to the stats about how often they would actually happen. Any other questions?
Does it mean we cannot rely on PagerDuty on Fridays?
Can you not rely on PagerDuty on Fridays? You probably can. No. No, for the most part, when we run this exercise, we find nothing. In a way, it's a little bit sad. Sometimes they get a bit boring. You're just sitting there kind of looking at graphs. A couple of times people have played music to pass the time, just because so often we run through the scenario and nothing bad happens. How was our response to the S3 outage? What can I say? We have a public postmortem. You can look at that. But that makes it actually sound quite a bit worse than it was. Broadly, we were just suffering from too much load for a sustained period of time. So for the first, I think, 2 or 2.5 full hours of the S3 outage, we were still up and we were still fine. It was only after a sustained load, we had a problem in one of our Cassandra clusters. There was basically a little bit of bad luck in terms of the hash distribution of a few hot keys focused on just a few nodes, and bad luck because those keys were rotated regularly, but they happened to hash to what resulted in the same nodes. So we did have some downtime then, but it came up in the postmortem that we were up for the first like 2.5 hours. Anyone who was affected was very thoroughly alerted by us before we had any problems. And even then, it was just some delays in notifications. Yeah. Any other questions? Yep.
Since you are the one who are actually choosing which server is going to be available for failure Friday, any advice how you restoring your reputation among the people in your company?
So as I am the one who picks which service gets hit, how do I restore, maintain my reputation? A lot of the culture is that we care about reliability. If Failure Friday shows something is wrong, then not that we would assign blame, but if we were, it would be your fault anyway for having that problem. Nobody would blame the person who discovered it, and we wouldn't blame the person who coded it either. We would just work on figuring out what we need to do to make it not happen in the future. Any other questions? No? Cool. Well, thanks again.